All right, I always start out with hope on Mondays. I don't have a bad case of the Mondays. I actually think there's a good chance by Thursday I'm defeated. All right. So this, especially I'll just say it this way. We close laptops. We used to identify people or kind of guess their field of expertise at the joint math meetings by just how they looked. Totally an uncool thing to do. But anyone who had iron pants and everything cleaned up, very tight, we thought they were an analyst, real analysis person. This class is the one where you stick to everything like glue. You look up all the facts. You don't say anything unless it's in the book. So make sure that you stick to your definitions, like Gorilla Glue, super glue. So everything that you have, you start out with the definitions first. So we need a definition of absolute value. If you were in my foundations class, you got this. This is it in Bartle's book. We're going to use the book actually tightly. That's very different than foundations. The book is your reference where you go to and can use things. And Kennedy and I went through a nice exercise. I wish I had recorded it yesterday, where we're just going through the book and hunting for everything that would help us write the proof that was given to you by Dr. Mohn. So you thought of in the past absolute value as just being this thing that makes numbers non-negative. You know how to calculate absolute value of -3, for example. The absolute value of -3 is 3. But if you think about what absolute value is, it really is a piecewise defined function. It's almost like the work that you've done in the past has polluted you from thinking of it. But if you look at it, look at the graph, it is a piecewise defined function, right? There's two chunks to it. When x's are bigger than 0, you draw it this way, it's y equals x. When x's are less than, if you program this, you would program it as a piecewise defined function. So that's the formal definition of absolute value. And it might seem very weird. For every definition, I have an example. By the way, I break this down into cases. So I think of it like, if I'm over here, I'm supposed to do this. If I'm over here, I'm supposed to do this. And if I'm at 0, it's supposed to be 0.
Bartle would do this ternary definition of ordering. Because if you could have done that 2 lines if you'd done A, if A is greater than A.
This is how he has it. This is very different than, in topology, I felt like I went by the book, but not this tightly. Real analysis is the class where you just use the book exactly. So I'm going through and just copying directly what was out of the book. So if I have absolute value of 8, a -8, A equals -8 is less than 0. So we're in case 3, and I pop it in there. The absolute value of -8 is -8, which is equal to 8. So it works just like a high school definition, but it's a formal definition of what we mean by absolute value. I work in the field of nutrition, and somebody once told me, you can't talk about how you feel about sugar or you don't feel about sugar. And I said, I'm a mathematician. I don't have feelings. It's a definition, and I go straight by that. I don't have any feelings. There's no feelings in real analysis. You don't feel something. You can think about it, intuition. You can talk about it behind your, cover your mouth when you talk about intuition, but you go to the definitions and the theorems and the facts when we write our proofs. No feelings. No emotions. That's how we singled out people at the joint math meetings of who might be a real analysis person. That person looks like they have no feelings. So there's these things in real analysis where you see these innocent looking theorems where that's so obviously true. I think that's why real analysis is considered such a difficult class, because you've had so much intuition up to this point. Calculus is real analysis without the theorems and the proofs. And so you've seen it, you've seen all these functions, you've worked with absolute value, and you think, oh, duh, I've used that. Absolute value of A and B is absolute value. I've used that before. All of these things seem like they're duh. Beware when they seem like they're duh. It's always a lot of, the more duh they seem, the more work it takes to kind of work it through. But you can't do proof by duh. Just so if you're going to do that in your notebook, duh, it's obvious that it's true, doesn't work. Beat Navy doesn't work.
Look.
Alex, this is kind of your thing. You seem to like real analysis. What does that say about you? No emotions, no feelings. You can tell anybody you're leading, I'm sorry, I don't have any emotions. I like real analysis. All right, got it down? I'm going to prove one. Well, some of it. And we're going to do some of it together. So let's prove C. Put the proof of C. Okay, the first thing, the reason I picked this is because if you didn't have foundations, if and only if sounds really great when you say it, blah, 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 if and only if, blah, blah, blah. But actually what it means for the person who has to do the proof, there's two proofs. So your heart should sink. So the first proof is if C is bigger or equal to 0, and this part here, I'm just picking the A, absolute value of A less or equal to C, then the other part is true. Minus C is less or equal to A is less or equal to C. And proof 2 that I have to do, I'm task oriented, I think of the work I have to do. That's the second proof. If C is bigger or equal to 0 and the conclusion from proof 1 is in now my hypothesis, then absolute value of A is less or equal to C. What you'll notice is Bartle's really sparse on the details. I've used different books over the time. I remember using one book, I think this is called Understanding Analysis. I picked it, and then one of my senior colleagues came by and said, good luck with that. Yeah, it was a disaster. It was just way too hard. But this one, I think it's got all the facts in there, but he skips on the proofs. So he doesn't actually put a lot of detail into the proofs. So what I'm showing you here is not in the book. It's all the details, and that's what you need. I think one of the things also, especially in real analysis, but for all proofs, you can't watch someone do 10 proofs and then be able to do the 11th one in general. But for real analysis, it's more tricky than that. So it even is if you find the style of proof, even that style of proof doesn't seem to transfer over to other proofs. But it does, just laying it out and organizing it. If you can't get your homework done all the way, at least organize all your thoughts, have everything laid out that you can do, show that you put thought into it, write notes to your instructor, and whether it's Dr. Mona or I, and say, I just really didn't understand where to go next. Text, getting that little nudge so that you get help. That's really important. All those things help you learn how to write these better. A cadet candidate asked me how he could learn how to write proofs. I'm I don't know, you have to actually get feedback and go through that process. I don't think you can just learn it on your own. So if I'm going to write a proof writing wiki. I don't have Alma Cooper in class anymore, but when I had her in real analysis, she said, ma'am, let's go back to that proof writing wiki, that little page that I sent out to you. You want to first write down what facts you know. And the first facts are the content between the if and the then is my know. So I need to write those things down. Writing never hurts you. You're not going to get extra calluses on your fingers because you wrote too much. It's going to help you think. It just adds another sense. So C bigger or equal to 0 is one of the facts. An absolute value less than or equal to C is another fact. I also have the definition of absolute value, which is stuck to me like glue. So there it is. So I wrote up all my facts. The reason you want to do all this kind of writing is so that you're trying to put a puzzle together. And if you know the puzzle pieces, but one piece is in the kitchen and the other piece is in the living room and the other piece is in the dining room, they're all over the house, you can't see those pieces. They're not in front of you. Nobody put a puzzle together that way. So you want all your things laying out in front of you so that you have them at ready disposal. Doesn't mean you're going to use them all, but you have them in front of you. And then Kennedy, we did that yesterday. We listed out, and you probably didn't use them all, but some of them look like they might be relevant, so we put them there. Got that? So I got it? I'm telling you, real analysis is the bean counters of the proof world. So we're bean counting here. So write down what you have to show. Well, that's the part after the then. That's this. That's the last line you write in your proof. I reached this as desired. Ever since we started using proof guides in my classroom, I've never had someone take what we have to show and use it as their no, but before that I did. So I think it's just organization. And it's a common thing where someone takes what they have to show and starts to use it as their no. You can't touch this. It goes at the very end, it's like your conclusion. So why did I circle it this way? Because that's the way I think of it. I think of it like a neon sign. This is my goal where I have to get to. And every once in a while I'll look up at that goal and say, that's what I'm supposed to get to. So you forget when you're trying to put puzzle pieces together, where you're trying to get to. Absolute value proofs are usually in cases because the whole thing, the definition of absolute value is by cases. So I just went to case one. What if A is bigger than 0? Then absolute value is A by the definition. I know I don't have it on the slide, but most of you are taking notes. So you have it in front of you. The definition of absolute value is sitting there. So you just go, pick it off. Absolute value of A is A by definition. And my no boils down to just C is bigger or equal to 0 and A is less than C because the absolute value of A is A. And C is bigger than or equal to 0 minus C is less or equal to 0. That's from Bartle. So I dug around Bartle and he says this. So here's what I have so far. I got minus C is less or equal to 0. A is bigger than 0, which is less than C. I'm almost there. It kind of looks like my neon sign where I'm supposed to get to. And so everybody's got a style of writing of their proofs. Dr. Moen and I probably have very different styles. I'm a throw everything up onto my canvas and then start editing my canvas. That's my style. So I've turned in lots of proofs as homework. No professor's ever complained about that style. It's just, I don't like to write. I like to have my thoughts all down first, and then I use arrows. Unfortunately, that's probably not the nicest way. You probably have, I've seen students write better kind of proofs than I do, but because I'm your teacher, you might adopt this habit. I've seen that come back at me. It's not wrong. It's just the way I like to do it. I like to put all my thoughts up there first and then say, this is why this is true and this is why this is true with stars and labels. So I labeled that one star up there so you can see it. And then I labeled this one by number over here so that you see that's where I got this from. Therefore, I got what I wanted. And just in case your proofs are not for you. So I had a student named AJ Bailey who's coming back here finally, but he argued that there's wrong and right proofs. There really aren't. I mean, you could have a flaw in your proof, but that's a disaster. Like if you have a flaw in your proof, there's something really wrong. But two people can write a proof. One could be easy to read and one could be completely difficult to read. The one that's easier to read is the correct proof. You want it to be as easy on your reader as you can. That's the whole goal of writing proof. It's not for you. It's not for your teacher. It's for the reader of your proof to make sure that they understand what you're trying to do. So I thought, I looked through my proof. I'm somebody who throws everything up on the canvas first. Looked through my proof and went, well, somebody would say, this is not what you wanted. This is what you wanted. Where did these things, can you imagine a plebe going, where did this come from that? I don't know. So I just added a little note. Hey, note, being strictly less than satisfies being less than or equal to, so that my reader knows that getting this implies this too. Good? Did I do it? Yeah, I did A equals 0. A equals 0 is trivial, but you still got to do it. That's really a lot of my problem. This is why I didn't become an analyst. I'd always forget the A equals 0 or the empty set being the set being non-empty, all these little details. That's probably why I went to West Point. Attention to detail was not my thing. But you have to work out that case, A equals 0. So again, I use the same approach. My no boils down to C being bigger or equals 0 and C being bigger or equals 0. I don't get anything new. So I just went forward and say if C is bigger or equal to 0, then minus C is less than or equal to 0 by what they said in Bartle. So minus C is less than or equal to 0, which is bigger. Like I just strung it through to make it look like my show. All right, take boards and showcase 3.